This is our home planet Earth. It's called the blue planet because most of it is covered by water. About 2/3 is covered by oceans and another 4% by fresh water in the form of ice sheets, glaciers, lakes and rivers. Water is key. We drink it and we shower with it. We irrigate our fields and crops if the weather doesn't do the job. Just as vital are the oceans. We catch 80 million tons of fish and move 100 million cargo containers across the high seas every year. The oceans may seem distant, but their role is so important in how our climate evolves. Ocean currents shuffle 1.5 million gigawatts of energy around the globe, and 1 trillion liters of ocean water evaporate into the atmosphere every single minute. The weather, the climate, the health of our environment, even most of our personal lives, all depend on the oceans. Still, our knowledge about the oceans is sparse, and we know even less about the deep sea. For instance, we know little of what's behind El Niño. We see parts of the Pacific Ocean becoming slightly warmer due to ascending underwater currents, resulting in abnormal weather. But we still can't forecast how El Niño affects the world's climate. Or monster waves. Every month, a few large vessels suddenly disappear on the high seas, some of them after a fatal encounter with a monster wave taller than a church steeple. We want to be able to detect these areas of extreme surges and route maritime traffic away from them. We know even less about the ice sheets around the poles and about glaciers. How fast will they melt due to global warming? How will warmer currents change global ocean circulation and change the sea levels? These questions are of urgent concern to 2 billion people on Earth, and concrete answers are overdue. If we knew more about the oceans, we'd better understand our entire planet Earth. That's why scientists have identified 50 different parameters to describe the Earth's physics. Things like air temperature, humidity, wind speed, water temperature, wave height, and many more. And they've realized that half of these 50 can only be observed by satellite. Now the European Space Agency ESA, together with the European Commission and EUMETSAT, has launched its third Sentinel satellite, a satellite dedicated to the oceans and the properties of water. Sentinel-3 will, for the first time, provide almost daily coverage of all surface water on a global scale, with information about its levels, movement, temperature, the wind speeds, and the water color. With these new observations, short-term changes will be observable, adding to the long-term monitoring of the oceans, a 20-year heritage of successful Earth observation missions such as ENVISAT and METEOSAT. Sentinel-3 will supply the world's supercomputers with fresh data for better weather and climate forecasting models, ship routing, and river-level predictions. It will observe the water quality in coastal environments, as well as the pollution in the atmosphere. And, in addition, it will detect forest fires on land and measure the decrease of snow, glaciers, and ice sheets on a global scale. The science of today creates the applications of tomorrow. Sentinel-3 is part of the European Copernicus program, helping us understand so much more about the oceans and our home planet Earth, the only blue planet we know exists.